जय हिंद स्टूडेंट्स, आप लोग कैसे हैं? आई होप यू ऑल आर स्टेइंग फिट, फाइन एंड हेल्दी. Students, always add wings to your imagination. Never ever hesitate to fly high. It is only when you dream of something big that you will try to achieve that through your hard work. So please keep doing the hard work, right? So regarding today's session, we'll be discussing a very important and interesting topic. Yes, we'll be discussing about human eye. It is one of the precious gifts given to us. Actually, man has made various cameras, various sophisticated cameras, hi-fi cameras, but our eye is even better than the best of the cameras available today. So, we are going to discuss about the eye and about the eye defects. In the previous lecture, we have discussed about the human eye. In this lecture, students, we'll be discussing about the common eye defects that a person may suffer from. So, we'll start with myopia, hypermetropia. These are the two common eye defects which we'll be dealing with. Then we will be discussing the causes and the cure of these eye defects, right? And obviously, students, I have included some very interesting visual clippings in this session so as to make this session much more enthralling, much more interesting and engaging. You will definitely like it. So I will recommend or I will request you to watch the video till the end. And in the end, I have summarized the entire thing with the help of a chart. Clear, students? So let's start with myopia. And just watch this visual clipping.
Person may suffer from a common eye defect known as myopia. Myopia is also known as nearsightedness. A person suffering from myopia can see only near objects clearly, but cannot see the objects beyond a certain distance clearly. If the object is placed closer to the eye, then its image is formed exactly at the retina, and thus the image is clear and distinct. But when the object is placed far away, then the rays after refraction tend to get converge at a point in front of the retina. That is, image is formed in front of the retina, and thus the image on the retina is blurred or out of focus. Now let's find out the reason for this. This defect in eye occurs when either first, the eyeball is longer than its normal size, that is, when the distance between the eye lens and the retina is more than the normal distance, or second, the focal length of the eye lens is smaller than its normal focal length. Thus, a person suffering from nearsightedness or myopia is unable to see the far off objects clearly. This defect of vision is cured by using spectacles or contact lenses consisting of concave lens. The myopic eye will get cured against this defect if it is able to see the objects at infinity clearly. In order to correct the eye for this defect, a concave lens of suitable focal length is placed close to the eye.
So students, I hope you have enjoyed this very interesting visual clipping. So I am very sure you have understood the eye defect, that is myopia or short-sightedness or nearsightedness, right? So we'll be discussing myopia once again, right? So let's summarize this particular topic. Myopia or short-sightedness or nearsightedness is a very common defect in human eye, right? And a person suffering from myopia is able to see clearly the nearby objects but is unable to see clearly the objects beyond a certain distance, right? So let's discuss it once again with the help of these diagrams, which are very important. Now look, students, you must be very clear that for a normal eye the range of the vision is 25 centimeter to infinity. 25 centimeter, as we are aware, it is the least distance of distinct vision. For a normal adult, it is 25 centimeter, right? It is the minimum distance at which an object can be seen clearly and distinctly when it is placed in front of the eye, right? And infinity is the far point of a normal eye. Clear, students? So near point is the minimum distance of an object from the eye at which it can appear to be distinct, clear, and very clear image, right? And far point is the maximum distance of an object whose image is formed at the retina, and it is also clear. So the range of vision of a normal eye is from 25 centimeter to infinity, right? So that has been depicted by this particular diagram. Look, students, this is the diagram for a normal eye. Now, in the case of a normal eye, N, it is the near point, which for an adult is 25 centimeter. It is represented by a capital letter D. It is represented by a capital letter D. It is the least distance of distinct vision, which is considered to be 25 centimeter, right? So when we see nearby objects, then what happens is the thickness of the eye lens is maximum, so that the focal length is minimum. That is what I have drawn this diagram. This diagram depicts this fact. When observing a nearby object, then the thickness of the eye lens increases and focal length decreases, right? So this is for a normal eye when it sees an object which is at a very near point, right? This is again the diagram for a normal eye for viewing far away objects. So here, if the rays are coming from infinity, it's a very far away object. So rays are coming from infinity, and again the image is formed at the retina. So this is the diagram for the normal eye, where in both the cases, whether we are viewing the object which is nearby or we are viewing the object which is far away, in both the cases the image is obtained at the retina, so that the image is clear, right? So this is for the normal eye. So the near point of the normal eye is capital D, which is 25 centimeter. The far point of a normal eye is infinity, right? Now suppose a person suffers from myopia or nearsightedness. Then what I have stated is, in the case of myopic eye, a person is able to see clearly the nearby objects. So this is the case of nearby objects. So no difference at all for a normal eye and myopic eye when an object is placed closer to the eye. So there is no difference at all. The myopic eye is behaving as a normal eye when viewing an object which is closer to the eye, right? But a myopic eye is unable to see the distant objects clearly. So what happens is, in the case of a normal eye, the image of a distant object is formed at the retina. But in the case of myopic eye, if a person is suffering from myopia, then the rays coming from a distant object, they tend to get converged in front of the retina, not at the retina. So this is what the diagram shows. So the image is formed in front of the retina. So as a result, the image on the retina is not clear. It is unclear or blurred. It is out of the focus. So this person suffering from myopia is able to see the nearby objects clearly. No problem in that. But is unable to see clearly the distant objects beyond a certain distance. Right? So what happens is, for a person suffering with myopia, his near point remains at 25 centimeter, which is the case for the normal eye. But his far point do not remain infinity. His far point would be less than that of infinity. Clear, students? So suppose the far point of this myopic eye is f dash, right? Suppose it is represented by x. X is the far point, which is less than infinity, right? So this person suffering from myopia can see objects clearly up to this distance, because as long as the object is kept at a distance which is smaller than its far point, then the image is formed at the retina. If the object is kept beyond this distance, then the image will be formed in front of the retina. So for a myopic eye, the far point decreases from infinity to say distance x. Right, students? Now we have discussed the reason for it. What may be the reasons? For what reasons this myopic eye tends to suffer from? First is the eyeball may get elongated. That is, the distance between the eye lens and the retina might be much more than the normal distance. And second reason, as we have discussed, is the focal length of the eye lens may get decreased than the normal case. Right? So these are the two reasons due to which this defect may occur. Right? And now its cure. How to rectify or how to cure this myopic eye? For that, students, we make use of a diverging lens. That is a concave lens of suitable power or suitable focal length. So look, when this concave or diverging lens is placed closer to the eye, then what happens is the rays coming from infinity, it gets diverged from the concave lens and then it tends to converge exactly at the retina. So what happens is, even if this person suffering from myopia is viewing object which is at a very far away distance, still by using this concave lens or diverging lens, its image will be formed at the retina. So clear image will be obtained, right? So by using a concave lens or diverging lens of suitable focal length, this eye defect can be cured. Now what we do is, this is where the image is obtained and object is considered to be at infinity. So what we will do is, we will try to find out the expression for the focal length of the diverging lens which is to be used so as to cure this myopic eye. Right? So concentrate on this particular diagram, students. Since we are making use of a lens, spectacles they are made up of lens. So we need to make use of the lens formula. And we are aware, lens formula is 1 by V minus 1 by U is equal to 1 by F. Isn't it? This is the lens formula. U is the object distance, V is the image distance, F is the focal length. Clear, students? And the spec is very close to the eye lens. So these two may be considered to be vanishingly close towards each other. Now, in this case, concentrate on this particular diagram. In this case, rays are coming from infinity. Rays are coming from infinity. So, object distance is infinity. Now, incident ray is traveling along this direction and we are supposed to measure the distance from the optical center. And in this case, it is measured in the direction opposite to which the incident ray is coming. Isn't it? So, that is why negative sign is assigned. And what about V? Its virtual image is obtained at this point, which is the far point of the myopic eye. And far point of the myopic eye is considered to be X. Again, incident ray is traveling along this direction and X is measured from optical center in a direction opposite to the direction of the incident ray. So, it will be again taken as negative. So, V is equal to minus X. Correct, students? So, let's substitute this value over here. What we get is 1 over, in place of V, write it as minus X. Minus 1 over, in place of U, write minus infinity is equal to 1 by F. 1 by infinity is 0. So what you get is 1 by minus X is equal to 1 by F. Or F is equal to minus X. So this is a very important formula. Right? Focal length of the spec to be used to cure the myopic eye is found to be negative. So negative focal length indicates the diverging nature of the lens. So the lens must be of diverging nature. It must be of diverging nature. That is, it must be a concave lens. And what what will be the magnitude of the focal length of the concave lens to be used? It should be equal to the far point of the myopic eye. Clear, students? Whatever is the far point of the person suffering from myopia, the focal length of the concave lens which he must use so as to cure this defect must be exactly equal to his far point. For example, students, I'll give you a simple illustration, giving my own example actually. I'm myself wearing spectacles, right? I'm unable to see the distant objects clearly beyond a certain distance. Beyond a distance of 200 centimeter, I'm unable to see the objects clearly. Clear, students? And I'm able to see clearly the nearby objects. So definitely, I'm suffering from myopia. Clear? And my far point is not infinity. My far point is 200 centimeter. It is because object placed up to 200 centimeter that can be viewed by me clearly, and beyond that distance it appears to be blurred or unclear, right? So my far point is reduced from infinity to 200 centimeter, right? So what is the power of the lens which I am using? So for that, what I do is X in my case is 200 centimeter, right? So what will be the value of f focal length of the lens which I am using? It will be minus x, so it will be minus 200 centimeter, that is minus 2 meter. So negative sign suggests that I must be using a diverging or a concave lens. And what will be its focal length? It will be 2 meter. Clear, students? So what will be the power of the lens I am using? Power, as you are aware, it is reciprocal of focal length in meters. So what I get is power, it would be equal to 1 by 2. That is, focal length is negative, so minus 2 per meter. So what I get is minus 0.5 diopter. Diopter is the SI unit of the power of the lens. So students, if my far point is 200 centimeter, then I need to wear a concave lens of power 0.5 diopter. And since I am making use of concave lens or diverging lens, power would be negative. I hope you have understood the concept, students. So again I repeat, in case a person is suffering from myopia, then what happens is the image of the distant object is formed in front of the retina. Second important point is, this defect may arise due to the elongation of the eyeball or the decrease in the focal length of the eye lens. And last but not the least, in order to cure this myopic eye defect, a diverging lens or concave lens of suitable focal length is to be used. And what is that suitable focal length? It should be equal to the far point of the myopic eye. And concave lens, diverging lens, so obviously its focal length or its power would be negative. Clear, students?
Hypermetropia is also known as farsightedness. A person suffering from hypermetropia can see the distant objects clearly, but not the nearby objects. It implies that the near point is not at the normal distance, but at some point farther from the eye. In case of a hypermetropic eye, when the object lies at the near point for the normal eye, its image is formed behind the retina. A person with normal eyesight can see clearly the objects lying between near point and the far point. When the object lies at the near point, the normal eye produces its image exactly on the retina. The eye achieves it by accommodating the eye lens to minimum focal length. While on the other hand, in the case of a hypermetropic eye, the image is formed behind the retina. This results into the formation of a blurred image on the retina. This defect occurs when either, first, the eyeball is shorter than its normal size, that is when the distance between the eye lens and the retina is less than the normal distance, or second, the focal length of the eye lens is larger than its normal focal length. Hypermetropic eye can be cured by using a convex lens, which is a converging lens. By placing a convex lens close to the eye, the rays coming from the nearby objects can be focused at the retina.
Another common defect in the case of human eye is hypermetropia, or it is also known as farsightedness. In case a person suffers from hypermetropia, then he is easily able to see the distant objects clearly. But in case of nearby objects, he is not able to see the objects clearly. Nearby objects, the image formed is blurred, because for nearby objects, the image is not formed at the retina. Here also, this is the diagram for the normal eye. In the case of normal eye, what happens is the eye, due to the power of accommodation, can adjust its focal length so as to see clearly both the nearby objects as well as the far objects. In case a normal eye views a close or nearby object, then the thickness of the eye lens is maximum and the focal length of the eye lens is minimum. And in case the normal eye is viewing a distant object, then the thickness of the eye lens is minimum and its focal length is maximum. So this ability of the eye lens to adjust its focal length so as to be able to see clearly the distant as well as the near objects, that is known as power of accommodation. Look, for a normal eye, whether the object is placed at nearby distance or it is at a very far distance, in both the cases, the image is formed exactly at the retina. So clear, distant image will be obtained, isn't it? Now, hypermetropic eye. What I've stated is, in case a person is suffering from hypermetropia or farsightedness, he'll be able to see the nearby objects unclear, right? He will be able to see the far objects clearly, but will be unable to see clearly the nearby objects. So look, concentrate on that particular diagram, right? In case the object is placed at a far away distance, then for a normal eye as well as for the hypermetropic eye, both the diagrams are same. Right? So, in this case also, hypermetropic eye, when the object is at a far away distance, then image is obviously formed at the retina. So, no problem in viewing the far away object. But, in case the object is placed at the near point, which for a normal eye is 25 cm, then what happens is, for a hypermetropic eye, the image is not formed at the retina, but it is formed behind the retina. So, as a result, it will be out of focus, and the image formed on the retina will be blurred. It won't be clear, right? So what I mean to say is that for a person suffering with hypermetropia, the far point of that person will be same as that of the normal eye, which is infinity. But the near point will increase. It won't remain 25 cm. It will be greater than 25 cm, as is depicted by this third diagram. Now look, if the object is placed over here, then its image is formed at the retina. So, if the distance of the object is reduced, then what happens is the image is formed behind the retina. In that case, it will be blurred. But beyond this distance, the image is formed at the retina. So, this person will be able to see the object clearly if the object is placed beyond N dash. N dash is the near point of this hypermetropic eye, which is represented by x, and obviously this x is greater than this distance, which is the least distance of distant vision for the normal eye. So x in this case is greater than capital T. Is it clear, students? So now, how to cure it? How to cure a hypermetropic eye? For that, what we do is a convex lens, that is a converging lens, is to be used. What it does is, this is a converging lens. Now, if the object is placed at this particular point, which is at a distance capital D, which is the least distance of distant vision for a normal eye, then what happens? After refraction, the image is formed exactly at the retina, and its virtual image is formed at the far point, which is x. This is x. Right? So, in this case, by using a converging lens of suitable focal length or suitable power, this person suffering from hypermetropia, by using this convex lens, will be able to see clearly this nearby object as well. Now, even if the object is placed at 25 centimeter or at the least distance or distant vision for a normal eye, then also the image is formed at the retina. So now his eye defect has been cured by using this converging lens, right? Now what we'll do is, we'll try to find out the expression for the focal length or the power of the converging lens which is to be used so as to cure this hypermetropic eye. And before that, we need to recapitulate the reasons or the causes for the occurrence of this hypermetropic eye. What might be the causes? The shortening of the eyeball. Right? This is the first reason. Shortening of the eyeball means the distance between the eye lens and the retina is less than the normal distance. Or, what's the second reason? The focal length of the eye lens increases than the normal focal length. So these two might be the reasons for this defect, right? And always remember, in the case of a hypermetropic eye, the far point will remain at infinity, but the near point won't be 25 centimeter. It will be greater than 25 centimeter. And last but not the least, in order to cure hypermetropic eye, a converging lens of suitable focal length is to be used, right? Let's find out the expression for the focal length of the converging lens which is to be used to rectify this particular defect, right? So, from lens equation we are aware 1 by V minus 1 by U is equal to 1 by F. This is the lens equation, we are very much aware of it. Now, in this case, for this lens, this will be the object. This is the object where it is placed. And we are considering the lens and the eye lens. The spec and the eye lens, they are placed very close. Obviously, lens is placed very close to the eye, isn't it? So they may be considered to be vanishingly closer towards each other. So the distance may be considered to be measured from the eye lens or from the optical center of the convex lens which we are using. So here, the distance of the object from this eye lens or from this optical center of this convex lens can be considered to be d. So u is equal to minus d. Why minus sign? Because the incident ray is coming along this direction, from right to left. But we are measuring the distance from the optical center from left to right, in a direction opposite to which the incident ray is. That is why this negative sign is assigned. We are using sign convention. Nothing new in it. What about V? This is where the image is obtained, at the near point of the hypermetropic eye, which is considered to be X. Again, the distance is measured along this direction while the incident ray is in the opposite direction. So V would be equal to minus X. X over here, remember students, it is the near point of the hypermetropic eye. It is greater than 25 centimeter. It is greater than capital D. D, capital D is the least distance of distant vision, which for normal eye is considered to be 25 centimeters, right? Substituting this value, what you get is minus, substitute the value of U as minus D. So, minus 1 by X plus 1 by D is equal to 1 by F. Let's take LCM. XD, it will be minus D plus X is equal to 1 by F. Or taking the reciprocal, we get XD divided by X minus D. So students, this is the formula for the focal length of the convex lens which is to be used so as to cure the hypermetropic eye, right? Now do concentrate on one particular thing. I have told you X, it is greater than capital D. Capital D is the near point of a normal eye. But for a hypermetropic eye, the near point is this one, which is obviously greater than capital D. So X is greater than capital D. So this entire term is positive. That is focal length is positive. So what does it indicate? It indicates the converging nature of the lens. So the lens to be used is converging in nature. It must be of converging nature. That is, it must be of convex lens. Clear, students? Okay, students. Now what we do is, we'll try to summarize the things which we have discussed in this session. Clear, students? So we'll try to summarize in the form of this particular chart. Students, believe me, it is a very, very important chart, and do try to understand this fully, right? Okay, let's start with it. Myopia, and this column will relate to hypermetropia. We have discussed, in the case of myopia, a person is able to see clearly the nearby objects. He is able to see clearly the nearby objects. But a myopic eye cannot see clearly the distant objects. So far away objects, he is unable to see it clearly. While on the other hand, in the case of a person suffering from hypermetropia, he is able to see the distant objects clearly. Far objects he is able to see clearly. But he faces difficulty in viewing the nearby objects. Right? So, for nearby objects, the image obtained in the case of hypermetropic eye is blurred and out of focus. Clear, students? So that's the basic difference. Now, formation of image. In the case of myopia, the image for the far objects is formed in front of the retina. It is formed in front of the retina. For far objects. While in the case of hypermetropia, for nearby objects, the image is formed behind the retina. So the image is formed behind the retina for nearby objects. Okay, now let's discuss the near point and the far point. As I told you, a myopic eye do not face any problem in viewing the nearby objects. So for near point, the myopic eye has near point of 25 centimeter. That is represented by capital letter D. It is the LED. While far point, it is X. It is less than infinity. So myopic eye, the near point remains at 25 centimeters, same as that of the normal eye. But the far point is not infinity, it is less than infinity. X is the far point. Right, students? In the case of hypermetropia, he is able to see the far away object clearly. So his far point will remain at infinity. Far point of hypermetropic eye would be infinity. But since the hypermetropic eye is unable to see clearly the nearby objects, therefore here the near point of the hypermetropic eye would be greater than 25 centimeter or capital D. Clear, students? Okay. Causes. In the case of myopia, as I have told you, the eyeball elongates. That is, the distance between the eye lens and the retina must be greater than the normal distance. And what was the second reason, students? The focal length of the eye lens decreases. These can be the two causes. What about hypermetropia? Just the reverse. In the case of hypermetropia, the eyeball shortens. It means that the distance between the eye lens and the retina is less than the actual distance. Or secondly, the focal length of the eye lens increases. Focal length of the eye lens increases, right? Now, let's differentiate these two in terms of cure. In order to cure myopic eye, we make use of a diverging lens. A diverging lens is used. That is, a concave lens of suitable focal length or power is used. While on the other hand, in the treatment of hypermetropic eye, converging lens is used. Converging lens means convex lens is used. Right? And regarding the formula, in numericals we will be using this formula directly, right? In case of myopic eye, the focal length of the diverging lens must be equal to the far point of the myopic eye. That is, in this case, f is equal to minus x. This is the formula. While in order to treat hypermetropic eye, the focal length of the convex lens to be used is given by x b divided by x minus b. X over here is the near point of the hypermetropic eye, and capital D is the least distance of distribution, which for normal eye is considered to be 25 cm. So students, I hope you have enjoyed this session thoroughly. So please concentrate on these topics. These are some very, very interesting, and I've tried to convince you in an interesting manner, right? So if you find this session useful, then do please recommend my channel and share the link of my channel with your friends. And I wish you all the very, very best. Keep studying well and keep yourself fit and healthy. Thank you, students.